Hi, my name's Alaric Aponte. This is my video submission for Project 3 with Dr. Ozbay. I will be doing the 20 hertz and 40 hertz for the wind tunnel since our group only consists of two people. I'll be taking those two frequencies. Starting off, you're going to pick over here Fluent, put in one of these standalone systems. Before starting your geometry, you're actually going to change your analysis type to 2D because that's what we're working on. And then you're going to right click geometry, and this where you're going to go to this sign modular. That's where we're going to start our actual shaping of the wind tunnel. Once you get in here, you're going to set the Z facing towards you, picking the XY plane. Before anything, we're going to set our units to inches. That's what we like to use in this project. And we're actually going to start drawing our shape now. Picking line, you're going to draw three lines going over the x-axis here. Oh, just control C that. Sorry about that. Drawing your three lines. Doesn't matter the length, we're gonna end up dimensioning it. We're actually gonna dimension that now, so you're just gonna pick general over here for the dimensions. For our project, this first line is our contraction chamber, which is 24 inches long. Over here, our test section is 12 inches. And then for our diffuser, it is 42 inches. Making sure all that looks good. We're just gonna move this over here real quick. Put everything in the middle. There we go. Now we're gonna go back to draw. We're gonna pick line again. We're gonna draw four lines now, coming straight down, all in between each point. Doesn't matter the length. Again, we're gonna the dimensioning all of it. Now that we got those, we're gonna go to dimensions. General again, we're just gonna set these dimensions right here. Don't worry about the last one because that one's going to be affected by the half angle of the diffuser. So we're just going to leave that with no dimensions. Now that you got those, we're actually going to set our dimensions. This diffuser height is 22 inches. Over here is our test section. So that's actually 6 inches. Same with this one, star six test section. So 6 inches again. Now to actually connect this to the shape, we're going to go to constraints, go to midpoint, pick this line. You're going to pick this first point here. Pick this line, pick this point here where our test section start, this line to this point where the test section ends, and then this line, which is our diffuser outlet, we're gonna put over here on the end. Now that you got that, everything's looking really good. We're gonna go back to draw, pick line. This is where we're actually gonna start drawing our whole shape. So pick this line to here, this to here, this point to this point here, and then finishing it off over here. You're gonna go like this, and then here. There you go. Everything's looking really good. Before we go anything, we're going to go over here to angle, to dimensions and angle. So we're going to set our diffuser. Our project gave us a half angle, which was 3 degrees. Since we're doing this outside angle here, that would actually be 177 degrees. There we go. See, not that sharp of an angle, so it looks pretty good. And then we're going to finish out the shape by drawing the entrance here. Just drawing two straight lines out. Again, doesn't matter the length, we're going to end up dimensioning it. And then here we go. We're going to go to dimensions before we draw that other line. Again, general. For our project, these two are both 15 inches. So just going to make sure we get that there. There we go. Looking good. Let's move this over here a little bit because we're going to work over here. And then drawing our final line, just covering up this inlet right here. There we go. That's most of our shape. We're going to clean stuff up, picking our selection tool here. We're just going to select all these inner lines that we're not going to use. Just picking all the ones that don't need to be there. There we go. Now that we got all that, you just delete those. And there we go. We have our shape. To make it easier, I like to put the wind tunnel to the origin. So we're actually going to pick the midpoint again, constraints and midpoint. We're gonna pick this inlet and set it straight onto the origin. Oh, I forgot to delete a line there, so just go here again, pick the line, and just delete. There we go. Now that we got our shape, we're gonna actually create it. So we're gonna go over here go to concepts, surfaces from sketch. We're gonna pick our sketch, make sure everything's highlighted, click apply, and then we're gonna generate. And there we go. There's our wind tunnel. So we're good over here on geometry. Just make sure to right click and update. Make sure you get that green check mark. Yep. And then we can double click mesh and start on that. Now that our mesh has loaded in, we can actually start. First thing I like to do is just Control E. I like to set the names for all the actual lines. So we're going to pick all these outside lines. And the way ANSYS work, when you put a name to the lines that actually has keywords and let it know what it is. So just click on N once you select it and you can put the name. So we're going to name all this wall. And then over here, click N, where this is our inlet. Oops, spelled that wrong. Inlet. And then all the way to the back here, that's our outlet. Now that we named all of them over here in name selection, we can check everything, make sure everything looks good. Yep. And now we can actually start a mesh. Over here in mesh, I'm gonna right click, we're gonna insert. We like to do method. We click the whole shape. Then over here where it says geometry, you're gonna hit apply. For method, you're gonna change from quadrilateral to triangles. And before you hit generate, you're actually gonna go back to mesh. And this element size, we're gonna change to 0.01, making sure everything else looks good. Yep. Now you can generate. Wait a couple of seconds for that to get generated. And there we go. Our mesh looking good. Everything else looking good. We have our names. We're good on the mesh here, so we can actually minimize this. Again, right click and update. Make sure you get that green check mark. There we go. Now we can start a setup. Before actually opening the setup, a little pop-up should show up. Here we go. Yep. You're gonna do double precision and solar processes. We like to do two, so it always works out. So then make sure you have those two right there, and then you can click start and wait for that. Okay, now that our setup is all fully loaded in, first off, we're going to start here with models. Over here in energy, we're actually going to right click this and go to on. And then for viscous over here, we're going to double click that. We're going to change it to laminar because we're working with laminar flow. There we go, everything looking good there. We can skip all over this and go straight to boundary conditions. Double click on that. Only thing over here we're going to change is our inlet, which for our inlet over here is where we're going to set our inlet velocity. So for this project, we got given a equation which was 0.2489 times the frequency minus 0.3718. First velocity I will be doing is 20. So calculating that, that gives you 4.6062 meters per second, but that's the test section velocity. So using AV equals AV, since we're in 2D, you don't really need to use an area. We can just use the height. So multiplying that number times 6, which is our test section height here, and dividing it by 22, which is our diff or contraction chamber here entrance, we get 1.2562, which that is our inlet velocity. So over here, we're going to set that number, 1.2562. Apply that there. Apply again, just to make sure, close. And then that's all we need for the boundary because the only thing else is our outlet, which should be a pressure outlet, and our wall, which is a wall. And then we can go, I like to check the values. So just go to reference values over here, compute from, hold on. Over here, compute from inlet, just making sure that velocity is right and we're good. Then we're gonna go to initialization, double click on that, just start the initialization. There we go, pretty quick. Now we're gonna run our calculations. For a number of iterations, I like to do 150. Just makes it quick and it's good enough. Calculate that. Give it a little second for all the calculations to be run. Wait for it to tell you it's complete. There we go. It was pretty quick. Now that we have all that, we can actually start with our assignment, what our assignment requires us to show, which part A requires us to show the contours for velocity and the three different types of pressure. So for that, we're going to go over here, graphics, double click on contours. We can name our contours up here. So first one I'm going to name is the velocity contour. And this is going to be our contour of velocity, making sure it's velocity magnitude. And then we can save and display that. Looking at over here, making sure how everything looks good, seeing how it starts slow, speeds up in the test section, then slowly starts diffusing, going slower. And then in same one, we can put our pressure contours. First one we're going to start off is just over here, contour pressure, and then we're going to start with static pressure. Again, looking at how our pressure starts high and then goes down and up throughout the chambers. And then we can change this also to our dynamic pressure. Looking at it here, again, how the different chambers change the pressure, how it starts up there and then goes down, or it starts off low and then goes all the way down. And then final pressure being total pressure. Save and display that. Again, we can see it, how the different pressures change throughout the chamber and the boundary layers. And yeah, that would be it for our contours. Of course, these will be put into our Word file where they'll be shown with a little more explanation. Now that we got the contours, we can exit out of graphics. And now for part B, it asks us for the plots of velocity and the pressures around the center line. So we're going to go over here to XY plot and plots. And then, of course, you can name them. So this would be first our velocity plot. First thing is adding where our center line would be. So you're going to go over here to new surfaces, line and rake. We're going to name this the center line. And that is starting at 0 and ending at the full length, which is, what was the full length? Jonathan, what was the full length? 2.3622. Right. Start now. So over here, it would actually be our full length, which in meters, it would be 2.3622 meters. So just creating that there before you exit out, make sure it's over here. Yep, looking good. So you can close out of this. And then this is what will create our plot. So first one's our velocity or velocity magnitude, making sure center line is our only surface picked. You're going to save and plot that. And then moving this over here. Here you can see how it starts off at the inlet velocity and then goes up into the test section velocity, which was like we calculate 4.6. And then it slows down when it goes to the diffuser. And then now looking at our pressures, we can start with static pressure, making sure again center lines are only surface picked. We can see over here pressure differences throughout the center line. Then we can go to, again, we can show dynamic pressure from here. Same plot, looking at the line, looking how it goes up and down throughout it changing for the chambers. Over here, looking at our X positions. And then last, we have our total pressure. Save and plot that. This one's the most sporadic one because it changes throughout the whole chamber. But yeah, those are everything, our plots. When trying to export our values, we go over here to write to file and order points. We write that to a file, and then we export that through a notes app, through a notepad, and then we just copy and paste that into Excel, and that's where we get our values. And yeah, we plot everything on some graphs on the Excel, which would be assigned to would be placed to this assignment. And yeah, that's that's this part of the project. Thank you for watching. So that was our 20 hertz. Now to do our 40 hertz, we do the whole process again, but actually we don't have to go that far to change anything. Since it's me, I'm not going to start from scratch since it's the same process. We're just going to go back here to our boundary conditions. and go to our inlet. And then we're going to edit that. Since the only thing that changes with the frequency is the actual inlet velocity, using the formula that we're given, the 0.2489 times the frequency, which is 40 now, minus 0.3718, it ends up all equaling 9.5842, which that would be the velocity in the test section, which of course would be a lot higher than our inlet velocity. So we use AV equals AV. And since it's 2D, again, we don't use area, we use the height. So timesing that number by 6, which is the test section height, and divided by 22, which is our contraction chamber height, we end up getting 2.6139. So that's our inlet velocity for 40 hertz. We're going to apply that, apply it again just to make sure, close. And again, I like to check the value. So just go over here, click inlet again, making sure it changed. Yep, we're good. And then initialize that. Click on OK just so it initializes again. And then we're gonna run the calculations again since we changed the new inlet velocity. Wait for that to calculate all 150 iterations. Runs it pretty quick. Now that you got that completed, again, same as before, looking at our contours, looking at our velocity contours, should all look pretty similar, just changes a little bit. Here's our velocity contour starting off slow, then speeding up as pressure goes down, and then slowly slowing down as it builds up. Looking at our pressure, we can start with static pressure. Again, starting really high and then going low in the test section, then going up again. Uh, then looking at our dynamic pressure, we can go over here and see everything again, same as before. Looking now, finding our total pressure. Again, so looking at the contour looks the same with the bondulus being the one that changes, but pretty much similar. And then for XY plot, same thing. Remember to do that center line surface and then starting off with velocity, making sure center line is the only surface picked, save and plot that. Again, looks pretty similar besides the fact that the velocity changes in the test section and down low and the inlet. And then for our pressures, the static pressure, again, pretty much looks the same, just the numbers change. Since it's the same wind tunnel and the frequency is the only thing changing. Looking at our dynamic, again, will look really same, just the numbers changing. And then for our total, same erratic, it's very erratic, but yep, there you go. That's it for 40 hertz.